Hello folks, we are back with the next problem. It's a problem number 24, very identical to the earlier problems that we did. So let's go through the question. What does it say? Show that the right circular cone of least curved surface and given volume has an altitude equal to root 2 times the radius of the base. It's a cone as we have drawn over here, and it says that it has a least curved surface, so it's a curved surface that we have to work with, and we have to show that it's least, and then they tell that of a given volume, and the volume is given. Okay, and then of course they ask us to show something that we can do later. So let's check now how we can do this. Yeah, so as usual, so let maybe RHL be the radius, height and slant height of the cone. Now, as we all know that it's the curved surface that they have asked, and curved surface area of a cone is pi r l. Again, there are two variables r and l, so there is a substitution which has to come there. Otherwise, we are not able to do the differentiation. So therefore, we will write. Obviously, we have to make something in terms of the other. So volume is given to us, but so that is going to come to our rescue. Here, we get to know that r squared plus h squared is l squared. So pi r l, that's our work there. And yeah, so and the volume v equal to pi over 3 r squared h. So let's check what should be the substitution. To start with, it is 3v over pi, whether we should substitute for h or for r. Let's take h over here, r squared equal to h. Let's make that kind of substitution and see what happens to this expression, r squared plus h squared equal to l squared. From 1, what happens to this expression? L squared is h squared plus r squared, where we have the h squared as 9v squared over pi squared r raised to 4 plus r squared. Just check, because substituting r squared is not going to make us in any way comfortable. If we would have substituted for r squared, then we would have got 3v over pi h for h, and then you have to square it. That will be very messy. So both ways it's correct, but we try to do a kind of substitution that will be lesser messy, so that you don't have to mess up with the work. Now, so you have got it like this. So probably let's equalize it. So multiply this by pi squared r raised to 4, so that we have the denominators equalized. 9b squared plus pi squared r raised to 6 over pi squared r raised to 4. So that's our L squared. But we know that for the curved surface area we require L. So let's take the root. So it's going to be root of 9b squared plus pi squared r raised to 6 over pi squared r raised to 4, which will work as root of 9b squared plus pi squared r raised to 6 over pi r squared when we take the root. Okay, let's go to the curved surface, see if it's going to help us. So therefore, curved surface area A can be called as pi r l, where we have L as root of 9v squared plus pi squared r raised to 6 over pi r squared. That's A for you. Now, having got A, this is perfect. Why? Because you've got everything in terms of R. So it's perfect. So we are ready for differentiation. Now, before we go for differentiation, there is one more thing that I would like to suggest to you. Because you've got a root here, it's going to be sufficiently messy because of the root. Every time you try to take the derivative, it's like a derivative of the root and derivative of the function inside the root. It's going to be sufficiently messy. So in such questions, it's fine if you take the square and then take the derivative. It's going to work perfectly okay. So before we go in for the derivative, let's square both sides. So when we square both sides, this comes to 9b squared plus pi squared r raised to 6 over r squared. I hope everything is okay. Pi r l. L for us is pi r squared. So yeah, you have got the r left. So it's like r squared times a squared is, yeah. Okay, so let's take the first derivative now. Therefore, dA square over dr, we are taking the first derivative. So in the first derivative, we have, or maybe we can write it as, instead of taking it as a quotient, it's better if we write it as r raised to minus 2 maybe, so that it's not so messy doing it. So you will have maybe r raised to minus 2 as it is. The derivative of this, let's take out 9b squared, no derivative. Let's take the derivative of this. It's going to be 6 pi squared r raised to 5. So also, if we keep it as it is and take the derivative of the next function, 9b squared plus pi squared r raised to 6. Derivative of r raised to minus 2 is minus 2 r raised to minus 3. Alright, so let's try to simplify this. 6 pi squared r raised to 5 times r raised to minus 2 is r cube. And here it is probably 2 times, negative 2 times 9b squared plus pi squared r raised to 6 over r cube if you want. Yeah, and then if you plan again to take the derivative of it in the next case, that is for the second derivative, let's see what happens. For this it's going to be 318 pi squared r squared, because we're taking the second derivative there. And here let's take the second derivative. You will have a minus 2 coming out for this particular bracket, r raised to minus 3. The derivative is going to be 6 pi squared r raised to 5. And for after you have kept it as it is, we have the derivative of whether we have done it right. 2, we have got the derivative of this term, which is we've got the derivative of this term, we've kept this as it is, and we've taken the derivative of this, which is like this. And now we are going to write this term as it is, 9b squared plus pi squared r raised to 6, and you're going to take the derivative of r squared, that is minus 3 r raised to minus 4 over uh, um, only for this. That's it. We have taken it as a product. So what is the problem is, you have taken the square and you have got the derivative over r, that's the first derivative, and this is the second derivative which has come there. Let it be there, means we'll simplify it later. And let's go quickly for the critical point. DA over dr, dA squared over dr equal to 0, which is you have got the simplified version, 6 pi squared r cube minus 2 times 9b squared plus pi squared r raised to 6 over r cube equal to 0. Let's equalize this, otherwise it's going to be very messy. So it's going to be 6 pi squared r raised to 6 minus 18b squared minus 2 pi squared r raised to 6 over r cube equal to 0. I think we'll have to move on to that side. Okay, anyhow, so this can be simplified, and this will, of course, the r cube to start with. Let's take it on the other side, multiply both sides by r cube so that the r cube vanishes, and the remaining, let's try to simplify and check how it comes. I don't think it will be sufficient this much place, but let's check. It is 4 pi squared r raised to 6, and you're left with minus 18b squared equal to 0. So you're having 4 pi squared r raised to 6 equal to 18b squared, or rather pi squared r raised to 6 is going to be 18 over 4 b squared, which is 2 9 times 2 2 times. Okay, 9b squared over 2 pi squared. Now see, the thing is, we can get the value of r from here. R is going to be, r raised to 6 is going to be 9b squared over 2 pi squared. You can get the r value from here, but then it's very difficult, to the power 6 and all that. So what we will do is, at this step, it is for us to find out, what do they tell us? They tell us to find out that the height is, sometimes. So we just catch hold of a term where we have all this together. Like for example, we have v squared equal to All right, so it is like, yeah, so we'll just catch hold of this. We know that v squared is equal to 2 pi squared r raised to 6 over 9. Yeah, so let's take this term. Hmm? Of course, we can make a substitution elsewhere, but this will be much simpler. From 2, okay, what happens? We get L squared to be equal to 9 v squared, and v squared for us is this, that is 2 pi squared r raised to 6 over 9 plus pi squared r raised to 6 whole over pi squared r raised to 4. Technically what you should do, you should get r and you should get L, and then you should show, that's what you have to show. Let me once again get next to what they have asked us. Show that the altitude has, so h and r, you have to get a relation. So let's check this. Where's our h? H is 9b squared. Okay, so L we don't require. Let's take the H. I think that's better. Let's take the H. H is equal to, since H squared is 9b squared over pi squared r raised to 4. Yeah, because I thought there was a relation with L. No, it is a relation with that. So let's catch hold of the r. R is this. So H squared is going to be 9 times, see, let's put this v squared over there. 2 pi squared r raised to 6 over 9 by pi squared r raised to 4. So this is cancelling. The pi squared can get cancelled. This also can get cancelled. Fine. So you're left with h squared as 2r squared. So h is equal to root 2r. That's exactly what they ask us. Technically what we should be doing is, from this expression get the value of r, and then from there get the value of h, and then substitute and find that out. But that is going to be very clumsy because it's going to go in the sixth root, and finding from the sixth root is very clumsy. So we do one intelligent move. What we do is, from the place where you have got the critical point, instead of getting r, you have kept it to r raised to 6, or rather you're keeping yourself to v squared, and that v squared in the height expression you're substituting, and it's the same as a critical point, but it's a convenient step. So we have taken height as 9v squared over pi squared r raised to 4. Here we have substituted for v. Technically we should have substituted for r, but we have substituted for v, but it's the same. So we have substituted for v, and that helps you to get the value of r very, very quickly. It's only when you substitute h and r in the sixth root that you'll come to know it's so clumsy. So this is a very intelligent move in which you are able to show that h equal to root 2r, hence proved. And we cannot call hence proved because we haven't shown the maxima or minima. So that also we will do, and then we can conclude the problem. So let's show that also. Least curved surface, isn't it? So that we will ensure and show that. Then only we'll be able to conclude the problem. So let's say, therefore, d squared a squared by dr squared. Yeah, that we will ensure once again is it's like 18 pi squared r squared minus 12 pi squared r squared. After you do the simplification, I'm also simplifying it, okay? So 2 times, and then you have this. So if I could open this, it's going to be 6. I'm trying to simplify it side by side so that we'll get it done quickly. It's 6, and it is r raised to 4 in the denominator. So you're having 9 b squared plus pi squared r raised to 6 over r raised to 4. Okay, so when we work this out, this is already 6 pi squared r squared, and this is going to be 54 v squared over r squared, and this is going to be 6 pi squared r squared. So that will make it 12 pi squared r squared plus 54 v squared over r squared. Now r, for whatever value that it is, it's going to be definitely positive. So it's very clear that this is going to be a positive value. So therefore, mini markers, and therefore it's a least, okay, hence put. So that's all about this voluminous problem, where we have so many aspects to take care of. You have to take care of the minimum part, you have to prove it. At the same time, you have to take the derivatives into consideration and bring it all together. And the catch of the problem is here. This is where it is. If you go for the traditional conventional way, it's going to be really messy. So we take this kind of a shortcut so that you get the work also. At the same time, we don't put in too much of efforts. So that's about it. With more problems, we'll meet in the next video, and when we meet next time, we suppose we should conclude this exercise. Thank you.